Not even close to the end, it's just beginning. Life is getting lighter while the days are getting brighter, yeah. And it's a good, I won't even worry anymore. Took all my cares, still can kick them all out the door.
So, which you guys here, who's involved in digital simulation? Who does digital simulation? A little bit? A little bit? Okay. Who? What do you think? Is the volume good? Is the volume good? Okay, great. So, how about who's involved in SoC integration? Involved in SoC, cool. And do y'all deal with standard interfaces like USB, PCI Express, things like that? DDR, custom chip? All right, okay. We got a lot of custom stuff going on here in Austin. Is everybody local or who's from out of Texas? All right, well, thanks for coming. Well, anyway, what I'm going to talk about here today is verification IP. So Cadence has a business in IP, design IP components, as well as verification IP, which helps people in the digital simulation of their SoCs, where they're integrating lots of different IP blocks together. And so I got a couple of slides to introduce the design IP part of our business, and then I'll focus in on the verification IP. Okay. So Cadence is ramping up our IP business, and we're putting together what we consider to be a new type of IP factory. And in the old days, what are your options? Well, one option is that you go to the flea market and pick the IP. Now, this is about 5 years ago. I went to visit one of my customers here in town at a big company, and I was asking him about IP and how many, IP vendors did they buy from. And he said, Tom, I've got a list of 200 IP vendors across the company. Now, it's a multinational company, but he goes, and that's a big problem for us because just managing the contracts for all these people is an incredible nightmare. And then, we're constantly shuffling releases and everything. So this approach, causes a number of problems. On the other end of the spectrum, you can have the superstore approach, like one-stop shop, right? And everything's nice and shrink-wrapped. But the problem is, if you need any special customization, that's going to be tough, right? Because this is the process of, sort of mass market, one size fits all. And what we think is that there's a room for a place in the middle, and this is what we think people really need today. And that is the IP factory. So this is a term that we've coined, where you have a broad selection of IP, but where that IP is highly customizable and configurable to meet your specific chip needs. And so the image we like to put out there is at Nike, you can go to their website, get their running shoes, and customize those shoes any way you want, right? And so that's the idea. Great product, highly reliable, very well verified, but also rapidly customizable to meet your needs. So that's a Cadence IP factory. And I mentioned that we've built our business through some recent acquisitions. Okay. Oh, so that's what this stage is for. Okay. All right. So through some acquisitions, we acquired 3 important companies. Tensilica. Has anybody heard of Tensilica? All right. So Tensilica does data plane processing cores. So think of taking like if you had a mathematical functions that you might implement in a DSP, but that wouldn't run fast enough, and so your alternative would be custom designed for that. Well, the Tensilica products kind of split the difference. They have programmable components, data plane processing units is what we call them, to help you implement that function faster and get the benefit of standardization like a DSP, but the speed benefits of custom design. And they've got over 200 licensees in most of the top semiconductor companies, and over 2 billion cores have been shipped with Tensilica DPUs. So Tensilica is now part of Cadence. And also Cosmic Circuits is another company that we've recently acquired. And so they're very strong in analog IP and PHYs and have shipped over 50 million ICs shipped with Cosmic Circuits IP. And then the third acquisition is Evatronics. And I encourage you to stop by their booth. So one of my new friends is over there, and that acquisition's in process. It'll be closed in a couple of weeks. And they bring in a lot of IP, particularly around USB, where their products have been very popular. And of course, Cadence has always been strong in DDR. And we introduced the world's first DDR4 and wide I/O IP solutions, and we continue to lead in the memory area. And so that's the new growth that we've had around design IP. And if we take a look at what that looks like on a chip, so these are the Cadence Classic product areas, now augmented by Cosmic and filled in by Tensilica, and with the remaining coming in by Evatronics. So with this portfolio, we have a real broad selection of design IP to service our customers. This slide right here just puts everything on one slide. You can see the whole product lineup. And if you want to know more about design IP, please come back on Tuesday, tomorrow at 2:30 to hear my colleague, Kevin Yee, will do a full presentation on design IP. So please come back for that. And also, tomorrow at 5 o'clock, now this is very important, come back here for free drinks, courtesy of Cadence. So we're going to have margaritas and fun stuff to eat, 5 o'clock tomorrow. All right? And every day, you can visit us at the Cadence booth. Has anybody played the Cadence Best IP matching game? Has anybody played that? Okay. So a couple people. You go over to the end of the Cadence booth, and we have a game that you can play on iPads. Okay? And if you have the best score, then you win a tablet, okay, every day. And if you don't have the best score, your name is still entered in a drawing for an Apple TV, okay? And if you don't think you're lucky, we give you this real cool magnet set. It's a refrigerator magnet thing where you can design your own chip on your whiteboard in your office. So trust me on that. Go to the end of the Cadence booth and play Best Match IP. So let's talk about verification IP. So the Cadence VIP catalog is the widestly used verification IP that you can get. So we've got support for over 40 protocols. We've got support for over 6,000 memory models that are grouped into these about 40 different categories. And then we have special products as well around the verification IP area for hardware acceleration to make it run 50 or 100 times faster than logic simulation. We got some power tools to boost your productivity, and we even have formal VIP that runs in formal analysis. Okay? So with that, we deliver people out of the box productivity. Now, what is meant by verification IP? So we have to think about, now we're here from different spectrums of the design process, right? But this really applies to functional verification. So we're talking digital simulation to make sure that your design functions properly, right? And the challenge that people face when you're doing SoC integration is you've got all these different controllers around your design. And each one of those controllers is backed up by some industry standard specification that's a huge incomprehensible document, okay? So like PCI Express is about a 1,000-page specification. It's enormous. And so if you're going to create essentially advanced simulation models to play against your design, let's say your design has a root complex, right? And so you want a PCI Express endpoint to test against it, then you're going to have to sort through those 1,000 pages and create a simulation model, which is verification IP. And that model needs to have these different things to be useful. It's got to have all the state machines that are specified in the protocol spec. And these state machines can get pretty complex now, especially since everybody is making their state machines more complex to add additional types of low power states. You know, you might have 3 different low power states you have to deal with. And you also have to have protocol checks. So the 1,000-page document has hundreds of requirements. The design shall do this, it shall not do that. XYZ has to happen within this timeout period, right? So the verification IP needs to have all of those requirements built in, so if it detects that your design is violating the specification, it'll flag you immediately. Print out a report at the end of the simulation. You have these different errors in your design. And then it needs to have test sequences. So the VIP needs to come with a comprehensive set of tests to stimulate your design under test and make sure that it's functioning properly. And then for verification engineers, they like to talk about things called a coverage model and a verification plan, and that's kind of like icing on the cake stuff, but makes the verification process more productive. So now, the question is, do you want to roll your own VIP? So to create VIP that has all of those things in it, first of all, you need deep protocol expertise. And you have to have enough time to get it done. You need to be able to support all the users in your company that'll use this stuff, and you're going to have to maintain it. And how do you stay current? Well, you have to stay current by doing what we do, which is attending the protocol committee meetings, keeping up on verification methodologies, and handling vendor interface. So here I'd like to say that our VIP is vendor independent. It works not only on the Cadence simulator, but also on Synopsys and Mentor simulators as well. And so, by delivering our VIP, we offload all that development work that you would otherwise have to do. And the way our VIP is architected is that the simulation core here at the bottom is optimized to run on the simulation engine. And then there's a multi-language test bench interface that supports a variety of test benches that people use today. System Verilog is a very common language. It has System Verilog support, has support for the E language. So there's the System Verilog UVM interface. There's the E language interface. This gray box in the middle, this methodology independent interface, is for the many people out there that are still using just regular plain vanilla Verilog or VHDL to do their test benches. Some people use C or C++ for their test benches. So they can connect to their test bench through this methodology independent interface. And then that connects to the optimized core. And there's cores for simulation and also for acceleration. And this acceleration involves using a Cadence Palladium hardware accelerator, which we have as an example of that over in our booth, that speeds up the processing of the design by 50 or 100 times. And so, as I said, it works not only in the Cadence Incisive simulator, but in the Synopsys VCS, the Mentor Questa simulator, and also in the Cadence formal verification tool and the Cadence Palladium accelerator. This VIP has been developed over a dozen years, and over that time our customer base has grown and grown and grown. So today we have over 500 customers who have verified thousands and thousands of designs with our VIP. And the special things about our products are represented by a little acronym we came up with called SMART. So you think of Cadence, VIP, SMART. And SMART stands for SoC and System Ready. So as we've seen, we have not only simulation models, but support for acceleration, which helps you speed up those big SoC simulations. Memory models. Our support for over 6,000 memory models lets you include all the memories that go around your design in the simulation. So your DDR, DDR4, LPDDR3, LPDDR4, the latest memory models. Availability is unmatched. We support over 40 protocols, as we saw in that big chiclets slide. And we work real hard to be first with new protocols. So every month there's some new protocol coming online. And so in the first part of this year, the USB group introduced something called SSIC, which is Super Speed Interchip. It's taking USB to be used not only as an external interface from your phone or tablet, but to connect the chips within the phone or tablet. And by doing that, you get to leverage the software ecosystem around USB. And so that's a big bonus for smartphones. PCI SIG is doing the same thing for PCI Express. They've introduced a new protocol called Mobile PCI Express, which does the same thing, taking PCI Express inside of a smartphone. We're the first to introduce verification IP for both of those. And real-world fit, meaning multi-language, multi-simulator. We don't make you use a certain language. We don't make you use even our simulator, because we recognize in the real world people want choice. And then technically advanced. And I've got a couple of slides to talk about some of the things that make our solution very productive. And the first of those things is called Triple Check, and it's the Triple Check IP Validator. Who likes that name? I love that name. I helped to come up with it. So anyway, but the validator is used to help test that your design is meeting fully the requirements in the protocol specification. And so there's three things that go into that. One is the test suite, another is functional coverage, and the other is the verification plan. And so the user sits at his console and opens up a GUI that helps to configure the VIP to match the design under test. So let's say, for instance, that your design is a PCIe root complex. So you need to set up the VIP to be a PCI Express endpoint. And so with this user interface, you'll start to select checkboxes to say, okay, my design is a root complex, and it has, say, 16 lanes, and all the other different things in PCI Express. And when you click each one of these categories, it opens up a new window and presents to you the things that are logical for a PCI Express root complex with 16 lanes, okay? And if it's generation 1 or 2 or 3, etc. But with all that, it sets up the VIP to match your design. So that's a otherwise time-consuming task that this process saves. And not only that, but triple check also pares down the test suite to select only the tests that are applicable for that kind of design, for your root complex design. So our test suite has thousands of tests in it, and maybe a bunch of those don't really apply to your design, right? Because it's got to cover all different configurations. Well, this will, like I said, pare those down to just the ones that make sense. Okay, so then you run your simulation, and it outputs a coverage database. And this coverage database is in native System Verilog and the E language, and that will allow you to import that into any simulation environment to go and debug it. So that makes it independent of the simulator in terms of debugging. Use any one you want. But if you're using the Cadence simulator, it will pull that in to a interactive verification plan. We call it a V plan. And what that is, it's a graphical representation of the protocol spec. So every chapter is represented by a different line. And if you double click inside of one of those lines, one of those chapters, it'll show you all the requirements inside the spec. And it puts a little rectangle off to the side, a colored rectangle, and that'll turn green if your simulation confirmed that your design meets the requirements in that chapter, okay? And it'll be like red if it doesn't, and it'll be yellow if you set a threshold that, like it's a warning area, warn me if it's below a certain amount of coverage. So in this way, we have this really closed loop system where it's easy to set up your VIP to match your design. It runs only the tests that are important, and then it matches it against the protocol spec so you know that you truly have covered everything in that spec. So that's the triple check, right? The 3 plays, that's the triple check. Okay. All right. The next power tool that we have is, there we go, that's triple check. So the next power tool that we have is Interconnect Validator. So in an SoC, you have your CPU cores, you have all your I/O blocks, the custom logic that you're developing yourself, right? And then to stitch that all together, you need an interconnect. So in your chips today, does anybody have like an AXI interconnect? AMBA AXI? Or AMBA AHB? Okay. So those are common and used in many different chips. PLB might be another one. OCP, the Open Core Protocol. So these are standard interconnect fabrics that people use to stitch together their SoCs. Now, this presents kind of like a special problem in verification. So all the stuff I talked about was making sure that the individual blocks are speaking the right language. They're obeying the protocol rules, right? That the USB block conforms with the USB spec, that the PCIe block conforms with that spec, et cetera, et cetera. But what about not only making sure, must be a fire drill. All right. Okay. Great. So in this case, we want to have VIP to check each one of these interfaces, right? To confirm that it meets the protocol specifications. But how do you make sure that the data comes out of the processor subsystem and goes through the interconnect and ends up at the right place, let's say at the SATA block? Or that the next transaction comes through the fabric and comes down here into this UART. Or the next one comes down into the Ethernet. The data really gets to the right place. So that's what interconnect verification is about. And the way we do that, we can do that with our VIP. So what you do is you place all the instantiations of the VIP in place for your design. And then you run your design, and a special VIP component called the Interconnect Validator will make sure that the data gets to the right place. And not only that, these networks can get pretty sophisticated where it might leave the processor subsystem as, say, 32 bits, but end up in like one 32-bit word, but end up over here as two 16-bit words back to back. Okay? So the Interconnect Validator monitors to make sure that that's happening correctly in accordance with the protocol rules. There might also be some arbitration that comes into play. You know, are things serviced in the right priority? So Interconnect Validator checks that as well. In the processor subsystem itself, because our phones and tablets all have multiple cores, those processors need to maintain a cache coherent memory setup. So if one cache gets changed, that the others get updated appropriately according to the rules for that processor fabric. And so the Interconnect Validator has the ability to handle this for coherent fabrics as well. And so all that data gets monitored and tracked over here in Interconnect Validator. And once again, your simulation results get displayed back against the vPlan so you can make sure that you're covering your protocol. Okay? All right. And now we've got a slide here on our AMBA VIP in particular. So in AMBA, we have customers have verified over 500 projects with our AMBA VIP. It's been very successfully run out. We use triple check for compliance. Has a lot of backing up verification methodologies that help out. We've been #1 in consistently delivering to the latest AMBA protocols as they come out, and support for all the major ARM protocols that are out there. In the PCI Express area, again, a very mature level of product. Again, backed up by triple check, using an array of verification technologies. As I mentioned, we support mobile PCI Express, which was just introduced this year. And we also support NVM Express, which is storage connecting, instead of like through a SATA, it's connecting through PCI Express, and that's called NVM Express, and we have VIP for that. We were the first to introduce that as well. And then for memory models, I talked about the wide availability. And the bottom line is here, pretty much every customer I've talked to is using our memory models for their memory verification. These came from Denali originally. We acquired Denali 3 years ago, and it's always been the gold standard for memory models. Okay. And this is what our product line looks like again. Let me get back to that for a second. So like I said, very wide protocol support. I challenge people. Every time I present this, I almost never hear somebody say, oh, you're missing this or that. We really have pretty much all the major protocols covered. And so why choose Cadence VIP? Really for two things: because it's proven and because it's the smart choice. So that's the presentation. Any questions?
Questions? Here.
Yes.
So suppose I'm a small company and I have my own IP, and I want to allow my customers to use it through Cadence VIP. Is that possible?
We don't enable anybody to resell our product. Okay, so we don't do that, but we are so widely used that many customers that you're talking to probably already have our VIP in one way or another, and
they would need to. I mean, sorry. I would have to describe this such that your tools can prove things about them, right?
Mm-hmm. Right.
Can I do that about my IP?
Okay. So one thing to point out, I guess, is what people look for in that case is they don't want to be locked in to a particular kind of VIP, right? That only runs on one simulator, right? And that's why it's very important to have the support for all the 3 major simulators out there. That's the #1 thing that people want to make sure, because if they get your IP, they don't want to have to get a VIP product that only runs on one simulator. So we got that. That's like a main objection. We've got that covered. We do have, we use a web service called Xuropa.com. It's Xuropa.com. And on that, you can log in and run demos of our VIP. And you're actually logged into the console through a VPN and running the software itself. So you can actually check it out that way.
Thank you.